So now we're going to look at using a PNP bipolar junction transistor. We're switching a fair amount of a current here, not quite a switch, it's a voltage follower, but PNP. So we're going to use the 2N2907 right there. It can switch up to about 600 milliamps of current. It can handle more current than the 2N2906, which is another PNP bipolar junction transistor, and there's a lot of other transistors. So I recommend one that can handle about 600 milliamps current. But the main thing is we get it darker, and there you can see that the LED gets brighter. Of course, didn't get darker. I just covered the light dependent resistor, which made the light dependent resistor get darker. That's the main component. This cap does about as good of a job as turning off all the lights. So now we'll do a step-by-step build. I'm pretty sure I'll have to turn the light about that far away to get a good look, but we should see that there is 2N2907 on this transistor right there, and that is how you know the part number of the transistor, because this is the TO92 package. The legs are they come spread out for some reason more than other ones. A lot of these other ones, the legs are just straight lines, the pins, until you bend them out a little bit, because they don't usually line up in the board as well as this one does right there, pre-bent. And it's a bipolar junction transistor. It starts with 2N. I looked at the data sheet though beforehand, and left pin is emitter, middle pin is base, right pin collector. That seems to be the pin layout for bipolar junction transistors when it starts with 2N. Now we want the emitter up higher because I'm wiring the board much like you see there. So we'll put the emitter to the top by swiveling it that way right there. Pretty straightforward. And I'm going to flip it around right there to make it a little easier to fit in the board. So the collector is going to the negative supply right there because it's PNP bipolar junction transistor. It operates the opposite of the NPN. And I'm just going to put it over there if it will slide in, just because then we got more room to wire other stuff. There we go. Finally went in. Don't force the pins into there, the leads. Just make sure you keep pressure on it till it goes in there. Now, the load is going to be a 5 volt 1 watt LED. So we can put up to 5 volts across it. Lower voltage would just mean less current. Of course, you need about 2.5 volts just to get a slight glow. About 3 volts to really get it to glow pretty good. And for the LED, and the rest of the voltage goes across the resistor to set how much current is going to flow. So the resistor and the LED are on this metal backing right there, heat sink right there, and there are little pads that I soldered these wires to. Pretty straightforward. And I don't want it to face the camera because it's really bright and obnoxious. So I'm going to have it so it goes to the right. So I got that little jumper going to the positive supply. Now we are going to take a, in this case, pull-up resistor, 10K resistor. What this does is, especially when you got semiconductors, sometimes they confuse the emitter to where zero, or in this case, the positive supply is. For the NPN bipolar junction transistor that's going to ground. So our voltage is actually going to be 0.6 volts below the positive supply right there at the base. This will be about 0.6 volts higher at the emitter. That's the main thing. So we got our variable voltage divider with the light dependent resistor. So 10K resistor is going to go from the emitter to the positive supply right there. So the opposite of the NPN. That's the main thing to be aware of. And again, we have the emitter at a base that builds up about 0.6 volts at the emitter versus the base right there. The base though is a variable voltage. So as we raise the voltage at the base, the voltage at the emitter will go higher. And we raise the voltage by shining more light at the on the light dependent resistor, and therefore higher voltage. This is the highest voltage. So a higher voltage is actually a dimmer LED module. Hopefully that makes sense. Now, we will grab, I guess, the photo down first. Goes to the positive supply. And so I usually have those connected up higher. I can leave a little space there, but it's going to the positive supply. Leaving a little space to make it a little easier to get the resistor. So of course the jumper is going up to the middle pin, the base of the PNP bipolar junction transistor. And now we will plug the fixed resistor to the negative supply. So the fixed resistor is trying to keep the transistor on. That's the main thing. If we didn't have the light dependent resistor, we would just have an on transistor. So the light dependent resistor, of course, the better it conducts, the more that it turns the transistor off. So more light, the better it is conducting. I'll turn the lamp this way and set this over so that we can see the power supply. So power supply is off. Pretty sure I wired everything up correctly. I was wiring some stuff to the wrong row in recent videos. So power supply is off. Turn it on. We got that slight glow. So far so good. Of course, it gets darker, brighter LED, as we said before. Pretty straightforward right there. So we're not getting the full 5 volts across the module right there. As I said before, the there's a, in this case, a rise that it makes it closer to 5 volts than what the base is. So already we lost some voltage going across the load, and we're not getting this to conduct fully either, the way that we got it wired up. We could, probably modify it to do a little bit better, but for the most part, this is just a demonstration circuit to get us a, simple basic night light right there. And that's actually, an okay amount of light if you had in a room where you just want to walk around in the dark or something, keep it close to the floor. You'll probably see most everything on the floor right there. Definitely reduce your chance of tripping on something by a lot. So, in any case, we looked at the NPN version. I stretched that video out a lot longer than that. But I think I'm going to wrap this one up right here. I think it's pretty straightforward. And if you saw the NPN version, it's all the same stuff that I showed, other than polarities are opposite. So the LED module isn't headed to ground. It's coming from the positive supply because it's a voltage follower. If we were just switching it basically on and off for the most part, with this setup, it wouldn't be instantly on and off, but be a much quicker off and on. Then we would have it on the collector side right there, and we wouldn't need that resistor. We just have a direct connection to the positive supply. But here we have it wired as a voltage follower. It's following that base voltage, but unlike the NPN, which goes down at the emitter, we got a higher voltage, about 0.6 volts at the emitter there. In fact, we'll actually look at that with the multimeter. So now we're going to measure voltages with the multimeter. Voltages are generally the most important thing to be aware of with circuits. Of course, there's resistance and current and other stuff going on, but voltages is the main thing that you're usually worried about. So I don't have to move the red probe for anything other than high current, which we're not going to measure. And I set it to voltage. It's set to DC. You could also measure AC just by pressing that button, but we're going to only be measuring DC. And so the cover for this alligator clip is the one that I use to cover the light dependent resistor right there. But otherwise, we have the alligator clip. So I just squeezed the wire onto one end, or the, I should say the, whatever clips, whatever those are, tabs, onto the jumper. I used a pliers, squeezed all around it. And here's the other side. So I just took one of these male to males right there. So our voltage that we're going to measure is in relationship to ground. So this is going to give us our 0 volts. And right there, negative supply is 0 volts. Now we got the red probe. It gives you the voltage difference that you touch to that probe, the red probe, versus the black one. I'm going to move it off to the side right there, so I got a little more range. So first off, we can measure the power supply. It's set to 5 volts. I think I showed that on the power supply before. And we got some resistance in the wires and stuff, so a little bit of voltage loss is going to happen along the way right there. Let me come to the other power supply rail. It might be a little bit higher right there because there's a little less connections going on. But in any case, first voltage we're going to look at. So as I said before, we're going to have a base voltage right there about 1.7, and the emitter voltage is going to be about approximately 0.6 volts higher, approximately. So that would be, I think, about 2.4 or so. And you can see the LED is lit up a little bit. So that's to be expected. That's really spot on, about 2.4. And so the lamp is at its brightest setting. I'm going to dim the lamp, and there you can see it went down a little bit, but that's a bigger voltage difference across the light dependent resistor module right there. So we got about 2.1. We're still going to be about a little bit higher with our signal voltage, by about the same amount of voltage right there. And then if I get it dark, of course, it goes up. And this multimeter automatically emits light. So we have about a 2 volt at the negative side of this module right there. So we got about 3 volts across it. So we can measure that by coming up here to the positive supply. So we got the full supply voltage now. But when I plug this now, we can come down to the negative side of the LED module. And of course, it's about 3 volts. So it's 5 volts minus that 2 volts that we measured when I get it dark enough right there. Approximate. Again, we're not going to have exact numbers. So we're not getting ever full 5 volts across this LED module the way that we have it wired up right there. We'd have to improve it if we really want to get 5 volts across it. But for this fade effect, as the lamp just got dimmer, that got brighter, lamp got brighter, that got dimmer, for that effect, it's better to have a voltage follower there. This just won't get as bright, but it might be bright enough as it is. So again, these are just demonstration circuits that I'm showing. They're intended to be heavily modified, and in fact, the vast majority of the time, you'll probably never need to make something like this. You can probably just buy a light sensitive module or something, but it's still good to have the basics of how to build them and stuff, so that when you're looking at a board that you got, maybe it's not working properly or something, you can figure a lot of stuff out because you understand basic electronics, how components go together. So that's it. Thanks for watching. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.